Hey guys, and welcome to another one of my videos. So in this video, we're going to primarily be covering the difference between casting and interfaces, but we're also kind of going to be dabbing into inheritance a little bit and classes to some degree. But the main focus here is the difference between casting and interfaces. And the reason I'm covering this is because I've had a lot of people ask me, like in the Discord or on YouTube comments, like, hey, is it better to use casting or interfaces? And well, that's a pretty hard question to answer. Well, it's impossible to answer that question really, because it's sort of like asking, is it better to use a hammer or a screwdriver, right? Because they both have different applications. Like a hammer is used for nailing things, and a screwdriver is used for screwing things in. So I'd really have to ask you then, okay, well, what are you trying to do, right? So one of them is not necessarily better than the other. They just have totally different applications, and people seem to think that they're these interchangeable things where you can use casting or you can use interfaces for stuff, and that's really not necessarily the case. You really want to use casting when you should use casting, and use interfaces when you should use interfaces. So this is just going to be an explanatory video. I have a little scene set up here, and I have some stuff already implemented just to give us a real world example that you can actually look at and is tangible to help you understand when you would use casting versus interfaces. So what we're going to do here is, I already have it set up so that when you walk into one of these colored blocks, it changes the color of your gun, and it also changes the color of the projectile that it shoots. So if I hit this brown box, it'll shoot this brown projectile. And what I want to do is make it so that if I shoot anything in the scene, like one of these chairs or even this little cat here, I want it to change the color of the thing that I hit to whatever color the sphere is at that moment. So it's sort of like a little painting game, right? So in order to do this, the first thing you might think about as a way to accomplish this is casting, right? So if you're not familiar with anything that I'm talking about, I'll try my best to explain things for beginners as well as for like intermediate people. But most programmers will initially come to the conclusion like, okay, I should use some sort of inheritance hierarchy for this, where I have a parent class for my furniture or my items, and then that parent class has the functionality in it to set the color of the object. So no matter what I hit, it all just kind of works. So we're going to kind of go down that method first, and then I'm going to explain why that doesn't work out too well in this case. So you can see what I've done here is I have my 4 different furniture items. I have my table, my lamp, my couch, and my side chairs here. And you can see each one of those is down here as its own blueprint. And then each one of these blueprints derives from BP furniture base, right? So if you don't know what derive means, I'll try to kind of explain this very, very quickly because it's not really the point of this tutorial. But in Unreal, or in a lot of programming language, there's this thing, or there's a concept of inheritance, and it basically means that different classes or different blueprints can inherit from other classes or blueprints. So a good conceptual way to think of this, like, is an example. So if you think of any type of hierarchy, so maybe we can think of food, right? So at the top of the hierarchy, you just have food, right? And then maybe below food in the hierarchy, you could break food down into fruits, vegetables, and meats, right? So then you have 3 subcategories. And then you could break each one of those down even further. So fruits you could break down into grapes and banana, and then vegetables you can break down to like carrot and spinach, and meats you can break down to chicken and pork, right? So you can keep breaking things down more and more and more, but the important thing is that as you break things down, they are still the thing above it, right? So in the case of like grapes are still a fruit, and fruit is still a food. So as you move up the chain, it still logically makes sense. And that's the way inheritance works as well. So you can see here, this is a really simple example. Furniture is at the top of the hierarchy, and then below furniture, I have 4 different categories. So I have a chair, a sofa, a table, and a lamp, right? But you could break one of these down even further if you wanted to have more control. So like, for example, you could have a table, and then you could break a table down into, like a foot table and a coffee table, right? So at a high level, that's sort of what inheritance is. And the cool thing about inheritance is that you can treat the child classes as any of the parent classes above it. So if you have a reference to a grape, in my other example, Well, you could easily cast the grape to a fruit because we know it's a fruit. You could also cast it to a food because we know it's a food. And it kind of allows you to share functionality. So anything inside of a child class will have access to the parent class's functions and variables. So in the case of like the food, if the food class at the very top had an eat function, right? Well, if you had a reference to a grape or a piece of chicken or the spinach, right? If you had a reference to any of those bottom level classes for foods, you could still call that eat function because it inherits all of the stuff from the classes above it. So that's sort of a very quick rundown of what inheritance is, and hopefully that kind of makes sense. So what I want to show you is that since each of these blueprints inherit from the same base class, we can make use of that to simplify our code significantly. So in our first person projectile, which is just this little sphere that gets shot out, inside of my event graph, I already have some code here. So what we're doing is we're looking at the hit event. So this event gets called whenever the projectile hits something. And what we want to ultimately do is we want to call the set material color function, which is, you can see if you look at the target is my BP furniture base. I want to call this function off of whichever object we hit, assuming the object we hit is a piece of furniture. And then we just want to destroy the projectile. So the hit event gives us the other actor that we hit. And this is where casting and inheritance comes in really nicely, because all we need to say here is cast to BP furniture base. And so what we're saying is take this object that we hit and try casting it to a furniture base. And so the cool thing about inheritance is that this cast is going to succeed whether or not this is a lamp or a table or a chair or any other type of furniture that derives from this furniture class that we've created, this base furniture class. And so by doing this, it allows us to very easily add more furniture without having to continuously add code to set the color of furniture, because the furniture color setting code is inside of this base class. And then we can just hook this guy up like so. And then one thing I just want to point out real quick is you notice it has this cast failed. And a cast will fail in a lot of cases. And the reason it fails is because you're trying to cast to something which is not part of that hierarchy. So going back to the food example, if we were to be shooting our gun and there was a bunch of food in the scene, right? And we hit a tractor. If we tried to cast a tractor to a food, it obviously would fail because a tractor would never inherit or would never be a child of food because tractors are not food, right? So in some cases, cast will fail, and that's perfectly fine. It's not going to give you an error, but it is going to run this pin right here. And so if you wanted to handle that case, you could do it right here. But in our case, we don't really care, right? Because if the ball hits a wall or something that's not a furniture, we just want it to fail and not do anything. So now if we run this and we shoot a wall, you can see it's failing. But if we shoot one of these pieces of furniture, it actually sets the color of the furniture to whichever thing we hit, whichever color we currently have selected. So that's a really good example of how to set this up. But the problem is this freaking cat, right? Because the issue is that this cat is a pawn, and all the other furniture is an actor, and we can't really make this cat a child of the furniture class because a cat is not furniture, right? I mean, technically we could do it, but it's going to mess up a lot of things and it's going to be kind of confusing, right? Because if we look at the hierarchies here, if you just hover over furniture, you can see about 5 down from the top, or yeah, 5 down from the top, it says the parent class is actor. So that means we're deriving from actor. But if we go and look at our little cat blueprint here, you can see his parent class is a pawn. So if we were to change our cat to inherit from the furniture, then his ultimate parent would be an actor, and he would no longer be a pawn anymore. And we need him to be a pawn because we need him to walk around, and we need him to animate and be able to pathfind and all that good stuff. So we can't really do that. So now we're at a crossroads here of, okay, well, what do we do? Because we can't just make this guy inherit from furniture because he's not furniture. So this is a perfect example of when um, interfaces are meant to be used. So hopefully that can make sense as a, like, oh, we ran into a problem. What is the solution? The solution is interfaces. And the reason it's interfaces is because we want to reuse functionality between classes that essentially have nothing in common. So let me say that again. So we want to use an interface here because we want to reuse functionality between classes that have like nothing in common and do not inherit from the same thing, right? So let's go ahead and I'm gonna be writing this like from scratch as we go, so I can show you how you would convert this over from using casting to interfaces. So the first thing we need to do is we'll just come out here and maybe we'll just do it right here. So we're gonna right click and create a new interface. I think it's under Blueprint, Interfaces. And then you can name it whatever you want. So I'm going to call it BPI for Blueprint Interface. And then I don't know what we should call this, like paintable. So the idea is that anything that we want to be paintable is going to inherit from this interface, or sorry, going to implement this interface. So you can already see the advantages of this because now no matter what we have in our game, it doesn't matter if it is in the same hierarchy or not, it can just implement this interface. I'll show you how to do that shortly and be able to implement the functions inside of this interface and be able to be paintable. So if we open this guy up, you can see it looks a lot like a normal blueprint, except it doesn't have all this stuff over here on the left where you can add variables and event graphs and macros and components, right? Like there's no viewport for it. All it is a list of functions that you can create. So if we come over here, it gives you one by default. So let's actually rename this to paint. So this is going to be the paint function, and then it needs to take in the color. So let's add an input parameter over here and then just call it, or sorry, we need to make it a linear color, and then we'll just call it color. I can type and then compile and save. So you can add as many functions over here as you want to an interface. So you can add another one and as many as you want, right? But for our case, for this particular interface, we really only need one function. We just need a function that allows us to paint whichever object implements this interface. So now going back to our cat and our furniture, we need to make it so that each one of these implements this interface. So that way they can share this paint functionality without having to somehow both inherit from the same thing. So let's go back to our furniture first and fix our furniture to use this interface. So the first thing we want to do is come up here to our class settings, and this is how you implement an interface. So if you go to class settings, you can see there's a section on the right for interfaces, and we can hit this add button and search for our paint interface. So here we have BPI paintable. And then when we do that, it adds it here to this list. And then more importantly, over here on the left, under interfaces, it adds the function. So if we take this function and we right click on it, we can then actually implement it. And when we do that, you can see it creates a new event for us called paint. And here is our color variable. And so what we want to do is we want to do whatever the furniture was doing before to set the color, but now we want to do it inside of this paint function. So if we look at our class, it's really simple. So I just made this function called set material color. And so all we're going to do is just call this guy from our interface and hook it up like so. So now whenever the paint event gets called via our interface, we're going to set the material color, which is going to change the color of the furniture. So now it's hooked up to use our interface. So now we just need to do the same thing for the cat, and then we need to update the projectile to call this interface. So let's go look at the cat. Cat, here he is. Open this guy up. So I believe for this guy, I haven't really done anything yet because I kind of wanted to show you guys how I'm doing all this coloring stuff in case you were curious. So what I'm doing is I'm taking the thing I want to change the color of, which in this case is the skeletal mesh. And then in the construction script, drag this guy in, and I'm saying create dynamic material instance. And then all you got to do here is select the material that you want to create the dynamic material instance for. And the reason you need to create a dynamic material instance is, if you don't already know, well, let me show you the material real quick, and then it will make more sense. So if we click on our little cat skeletal mesh, and we go to his material, we open this guy up. So you can see the way this material is set up is it has, most importantly, this color variable up here at the top, and it is going into the base color. So whatever value is set for color is going to be ultimately the color of our cat. And you can change this variable before you start the game, but if you want to change it during runtime or while the game's running, you need a dynamic material instance. So that's the reason we're creating one of these dynamic material instances. And then the source material, you just select, like the material. So we have m low poly cat, so we're going to select this one. And then, it looks like I already made a variable for it. But what you could do, I'll just delete it. So what you can do is just right click on the output pen and promote it to a variable and call this our material instance. So now we have a material instance, which is going to allow us to change the color of the cat at runtime. So now we also want to implement this function or this interface and make use of this material instance. So if we click on class settings, just like we did for the furniture, we want to add our BPI paintable. And then again, right click, say implement. And then, sort of like we did before, we want to change the color of the cat. So before, I already had a function which would do that for us, but I don't have one. So we're going to write it real quick ourselves. So I'm going to drag in the material instance, and then I'm going to call set, set vector parameter value. So what this does is it sets a parameter inside of our material. And the material is over here, and the parameter that we want to set is called color. So we want to make sure that we pass in a parameter name of color. And then for the value here, it is the value that we want to pass in. So we're just going to pass in the color. And then I think that's all we need to really do. So now we have our cat and our furniture base class both implementing the paintable interface and both implementing the paint function and both changing the color of their respective mesh. So the last thing we need to do is go back to our projectile, and instead of casting the thing that we hit to a furniture, we need to check if the thing that we hit implements this paintable interface, right? Because now we're going to be painting more than just furniture. We're going to be painting furniture and cats. So we can't simply cast. Well, actually, let me point out one thing. We could still do this using casting if we did something like this, and this is a bad idea. You don't want to do this, but I just want to point it out because I've seen some people do it, and it is technically possible. So what you could do is you could say, okay, my cast to a furniture failed. Let me try casting to a cat. And you can hook that up to the failed. And then if that succeeds, then you can come up here and, well, I guess you would need to call your own function inside the cat. So you could call a function inside of your cat, which we don't really have one, but you could call a function inside of your cat to set the material color and then destroy the ball as well. So you could do something where, like, if you have cats that are paintable, you have furniture that's paintable, and maybe you have, like, I don't know, scenery that's paintable, like trees and stuff, you could just keep casting and casting and casting and casting until one of them succeeds, and then you could set the color of that one. But obviously that doesn't scale very well, right? Because then you're just gonna have a bunch of casts and casts and casts, and it actually kind of gets expensive because you're just continuously checking and checking and checking, what did I hit, what did I hit? So you don't really want to do it that way. So like I was saying, the real correct way we want to do this here is, let me get rid of this stuff. We'll keep this little destroy over here. So what we want to know is, does the thing we hit implement the paintable interface? So we can take this actor, and there's a handy little function for this called does implement interface. And so this is going to return true if it implements whichever interface we specify here. So obviously we want to search for the paintable interface, and then we'll drag off of this guy and do a branch. And this is, again, checking if it implements the paintable interface. And if it does, then we know we can safely call this paint function that we've written, because remember, this has a paint function. We can safely call that function. So let's just move this over, add a little reroute node here. So if we drag off of this, we can call that paint function. So you can see it's under BPI paintable. So this is one we want right here. And we're going to hook this up to the true, and then finally destroy the actor after that. And so for the color, it's just going to be, again, the color of the projectile. So we'll drag that in, and there we go. So now, just to recap here, what this is doing is when the projectile hits something, it's checking if the thing that we hit implements this paintable interface. So the cool thing is that, like I said, anything that implements this paintable interface, the projectile will now be able to paint. And we don't have to ever change the code inside of the first person projectile ever again. And it's better than casting because it doesn't matter if things that the ball is hitting are inherited from each other. As long as they implement this interface, we're good. So if it implements that interface, then it calls the paint function and it destroys the actor. So now if we run this, hopefully this works. Let's try shooting the cat. Okay, so there we go. So now we change to white and to blue. And hopefully, yep, we can still shoot our furniture and things work out nicely. Yeah, so I think that pretty much concludes the video. Hopefully that makes sense to you guys of when you should use one versus the other. If you guys like the video, please leave a like and subscribe. I also have in the link, or in the description of this video, there's a link to my Discord if you guys want to join. There's also ways to support me, like via Patreon or crypto or donations of some sort. So if you guys want to do that, that's always also very appreciated. Otherwise, I will see you guys in the next video, and thanks for watching.